Now that we've worked with how to solve quadratics, we're going to look at rational equations. Rational equations will have a variable in a denominator of some type of fraction, and we'll be getting that out of the denominator in order to solve for our x. So some of you may be thinking, I have no idea what she just said. That's okay, we'll get there. So for instance, let's say that I had 18 over x plus 1 equals x minus 6. Okay, so if I were looking at any type of fraction, my goal here, if I'm looking just at this left side, if I was looking at this fraction and I wanted to get that x, first thing I'm going to do is I'm going to multiply both sides by the denominator in order to get rid of the fraction. So step one, get rid of fraction or fractions. So we're going to do that by multiplying by the denominator. So looking at that, I'm going to multiply both sides by x plus 1. I'm going to move this square here. Step 2, I'm going to distribute. So what happens here on the left side, when I'm multiplying on top, if I have 1 over 1, that just cancels out. Or if I had 8 over 8, that cancels out. It's the same concept. If I have x plus 1 on the top divided by x plus 1 on the bottom, that cancels. So that's how I'm getting rid of my fraction. So I have 18 equals x minus 6 times x plus 1. So I did my distribution kind of in step 1 there a little bit, but I didn't distribute the second side, which is what I need to do now. So I have 18 equals x times x gives me x squared, and then x times 1 gives me plus 1x. Now distribute on the bottom, I have negative 6x minus 6. I'm going to go ahead and combine my like terms underneath that distribution step. So I have 18 equals x squared minus 5x minus 6. So now looking at this, I have a quadratic. We've worked with solving quadratics. There are 4 different methods you could use. You could do it algebraically, by factoring the quadratic formula, or by completing the square. So step 3, solve the quadratic using the method of your choice. So for this one, I'm actually just going to factor it. So before I even get to the factoring, I know right away I'm going to have to move that 18 over so it equals 0. So 0 equals x squared minus 5x minus 24. So I'm going to, like I said, factor. So I'm factoring by AC, which 1 times 24 gives me 24. So I've got 1, 2, 3, 4, 6, 8, 12, and 24. Match up the appropriate sets. My goal here is to get to negative 5x. If I have a negative 8x plus 3x, that gives me a negative 5x. So I'm going to rewrite this then so I can group. 0 equals x squared minus 8x plus 3x minus 24. Like I said, I'm going to group this now. So I have x on the outside and then x minus 8. I'm going to group the next two. And I have a plus 3 and an x minus 8. Notice my parentheses, they're both the same thing. So 0 equals x minus 8 times x plus 3. And now I need to break this off. So x minus 8 equals 0, and x plus 3 equals 0. So I've got x equals a positive 8. Then I have an x equals negative 3. Now, some of you might be saying, okay, well, this line here is pretty similar to this line here. Now, why couldn't I just say x minus 6 equals 18 and then x plus 1 equals 18? Why didn't it work? It didn't work because when we're solving our quadratics, we need it to equal that big 0 there. So don't think that just because you have it factored, you're done, because you're actually not. You need it to equal 0. Now, sometimes there are more than one fraction. So I could have 2 over x plus 2 plus 3 over x minus 2, and that equals 1. So this time, I have 2 different fractions and my variable is in the denominator of both. It's the same process. It looks a little different when you get to the distribution part. So I'm going to multiply, well, by the denominator of both fractions. So I have x plus 2, x minus 2, all times my big component there, what's written in black. All right, so I'm going to get rid of my fractions. I'm actually going to rewrite this a little bit. Some of you might skip this first line and then just jump to the second step. That's okay. So I have x plus 2 times x minus 2 times 2 over x plus 2. So it's like I'm distributing, but yet I haven't really distributed yet. Okay, so what I've distributed is that blue part on the outside, but I actually haven't truly multiplied anything yet. And that equals x plus 2 times x minus 2. So over here on the far left, I already know that I can cancel out this x plus 2. So that's really 2 times x minus 2. Now let's look at the middle part. The x minus 2 cancels out as well. So I'm left with 3 times x plus 2. And then the far right side, I haven't done anything. I don't need to cancel anything out yet. So I still haven't actually distributed anything yet. So now I'm going to go ahead and distribute. So I have 2x minus 4 plus 3x plus 6 equals x squared minus 2x plus 2x minus 4. Okay, so I know my goal is to get to 0, but I'm actually going to combine some like terms first and then rearrange this a little bit. So looking at the left side, I have 5x minus plus 2 equals x squared minus 4. Again, my goal is to equal this to 0. So I'm going to move this over. So I have 0 equals x squared minus 5x minus 6. So again, I said you could use the method of your choice. I'm going to use the quadratic formula for this to kind of give you guys some options here. So in our case, a equals 1, b equals -5, and c equals -6. So I've got 5 plus or minus the square root of -5 squared minus 4 times 1 times -6 all over 2 times 1. So remember, I told you guys to simplify underneath the radical first. So I have 5 plus or minus the square root of 49 all over 2. Well, the square root of 49 actually works out, so we have a perfect square. So I have 5 plus or minus 7 all over 2. I'm going to split this. 5 minus 7 over 2, which is really -2 over 2, which is -1 then. Then on the right side, I've got 5 plus 7 over 2, which really equals 12 over 2. which gives me 6. Because this takes a little bit time-wise, and I'm already cutting her close on the minutes, I'm going to stop for now. I've given you 2 examples. It's the same type of process, and we'll work more with this in class.